everyone. This is Nugroho Putu Wicaksono, and I want to present my homework one number 4 with topic of advanced pneumatic, and the specific task is to design and simulate real hardware, electro-pneumatics and microcontroller with signal flow of A plus, B plus, A minus, B minus. Based on the pattern, we know that this signal flow is not uh, use cascade control, so we just design the usual one. The component that I use is same with the previously I present the recording, previously recorded presentation. This is the double lightning cylinder, flow control valve, limit switches, and push button, and 5x two-way double solenoid valve. And the other component for the electronic components, specifically for microcontroller, I use microcontroller this one and power supply of 24 volts. Due to the specification of 5x two-way solenoid valve. And this is the Arduino Uno. The Arduino Uno will read the digital input from the button, the limit switches, and the relay for channel relay is used to control the solenoid valve Y1, Y2, Y3, and Y4. And I also use 10 kilo ohm resistor. They were used as I forget whether this is a pull up or pull down resistor, but one of those. So this is the software that I use. I use the version of IDE Arduino 2.3.4, and for the dependencies I use PLC lib, and this is the version 2.0 beta 6. So it was maintained by Stephen Tosick, and previously it present and also Walter Ditch. So the signal flow is like this one. This is the initial position, step 1, step 2 A plus, step 3 B plus, step 4 A minus, step 5 B minus. This is the signal flow. Start A plus, and then A plus is hit the LS2, limit switch 2, and then limit switch 2 trigger the B plus, cylinder B move forward, and then it will hit LS4. LS4 gonna retract and make the cylinder A retract, and it was gonna hit the LS1. LS1 gonna trigger the cylinder B to move backwards or retract. So this is the wiring diagram. As you can see, this is the wiring diagram. This is the solenoid valve. This is as you can see, this is Y1, Y2, Y3, Y4, like that. This is connected to the common and normally open side of the relay channel. And this is for the limit switch 1, limit switch 2, limit switch 3, limit switch 4, like that. This is the resistor. Okay, and then this is the start button, like configured like this one. And for the power supply, and for supply, this is the minus. This is 24 volts, the minus, and this is the 24 volt. So the common is connected to 24 volts, and the NO pin connected to the solenoid, and the solenoid connected to ground, like that, the ground of 24 volts. Okay, this is the connection of the wiring diagram. And for the limit switch, we only use the 5 volts, 5 volts power supply. This is the 5 volts. Sorry, this is the 5 volts, 5 volts, and this is ground. 5 volts. This is also 5 volts. This is ground, and the common connected to the 5 volts, resistor connected to the ground, and between the resistor and the limit switch connected to the Arduino pin of input. Okay, and then I will back to the presentation. This is the schematic as I present before, and this is the electro-pneumatic diagram. Okay, this is A plus B plus A minus B minus. So this is the signal flow. This is the design of the component, and this is the ladder diagram. I use LD micro. Sorry, I will open, and this is the LD micro. As you can see, this is just for convenience of drawing the ladder diagram, but actually it can be used to download to microcontroller also. Okay, this is the ladder diagram, and from the this ladder diagram, we need to, what is it, to convert it to the Arduino code using the PLC library, PLC lib, like that. So this ladder diagram actually same with the pneumatic, like this one, exactly the same. Start button LS3, start button LS3, and then Y1, LS2, Y3, LS4, Y2, LS1, Y4, same. And then we will convert it to the Arduino code using PLC lib. So for the round one, we knew that X start or start input. Before I continue, wait. Before I continue to the, what is it? The converting the ladder program to the Arduino code, we need to see the reference manual that there is a custom pin configuration that we need to set. So we need to set that there is no pin definition, no pin default. Sorry. So if we want to use select random pins to connect it to our system, and we need to define no pin def, like that. So in my code, I will define no pin def, and then I include the PLC library, and I use this one. I initialize that start is connected to pin 8, LS1 to pin 12, and so on, like that. Y13, Y1, Y2, Y3 is like this one. Okay, and connected to this one. And back to the simulation, to the code presentation. This is the ladder diagram. The ladder diagram consists of start. Start is connected to this one, is it start pin 8. So DIN digital input start, so it read digital input of X0 start pin 8, and because this is N like that one, so it's gonna read LS3, and the output is gonna be send the result to Y1 like that. This is T out to Y1. Okay, this is it's different, sorry. T out, and for the second run, this is run 2, so this is gonna be D in LS2 and D out D out Y3, and for this one is D in LS4 and D out Y2, and so on like that. Okay, and I will present the video. This one. This one is the video of pneumatic. Sorry. This is the compressor, and the compressor connected to the manifold like that. And then this is the code, and this is the connection. We need to build. We need to solder a special banana jack and cable to connect to the Arduino or breadboard. We buy the component. Sukma and I buy the component at the nearby electronic stores, and we need to solder it by ourselves to complete this task. Okay, this is the connection. Okay, this is the pull down resistor connected to this one, and all the jumper here connected exactly to the module. And this is the, what is it, the 4-channel relay module. This is the Arduino code, and this is the start button. If I push the start button, the cylinder will move exactly what we designed to move. I forgot to mention maybe that this is the power supply of 24 volts. Okay, for the slow motion of video is this one. Okay, that one is the connection. This is the slow motion of the video. A plus, B plus, A minus, B minus. Okay, so if I press start, A plus, B plus, A minus, B minus. Okay, and I'm gonna push the start again, A plus, B plus, A minus, B minus. Okay, thank you for your kind attention, and I think that's all that I can present for my homework 1 number 4. Thank you.